Hello, Dua. Hello, Jishin. Welcome to the class. Tor, what are you trying to ask, dear? Channel में systematic content नहीं आता है. Yes, Jishin. Jenish, what is your concern? Tell me, what is your concern, dear? There is no systematic video in the channel. Do not worry. All those difficulties that you're facing will be rectified soon. You just have to let us know. Okay, you just have to let us know. And we'll be organizing the classes accordingly. You have term 1 exam in few days. Yes, I know that. And how's your preparation going, Thor? Thor, I'm planning to take matrices and determinant in one shot, but since our time is constrained to 1 hour, okay, so I'll be taking it in 2 parts. Okay, I'll try to finish it in 2 parts, max to max 2.5. Okay, so today will be our part 1. Tomorrow will be part 2. Mostly I'll try to finish it by part 2 itself. If not, we'll do part 3 where it will be filled with, half of the session will be filled with questions. Okay. So I believe we'll start the session. Myself, Alaka, and your mathematics educator in Unacademy. I've completed my master's from Manipal Institute of Technology. I have more than 5 years of teaching experience, and if you want to reach out to me, you can either use my Instagram handle or my Telegram handle. Also, you can use the code Alaka Live so that you will be getting a 10% discount on your subscription purpose. Also, you can follow my profile in Unacademy app so that you will be getting updates regarding my classes as well. There are a few announcements to be made. Yes, that is our Unacademy Super 20. Okay, so top 500 rankers stand a chance to attend a 2-day in-person bootcamp, personalized scoreboard and analysis session by top educators. And you can participate, crack and win up to 100% scholarship. Okay, you will be enrolling using the code Alaka Live or Alaka 10. Okay. Yes. Also, yes. Also, a really good deal is going on with IIT JEE Mega offer. If you are buying a 18 months ka subscription either in Plus or Iconic, you'll be getting 3 months ka extension. Okay, and this is valid till 30th of November. And with 6 month subscription, Iconic subscription, you'll be getting 1 month extension. This is also till 30th of November. Now, All Stars Crash Course 3.0 batch is starting from 1st of December, that is for class 11th, and you'll be completing the 11th ka syllabus in 4 months. These are our top educators who will be in charge of those classes. Okay, and now Ask a Doubt in Unacademy app has become with new features, that is you can upload up to 3 questions at a go at one time. Okay, and get solutions in your preferred languages, say English, Hindi or Hinglish. Okay, you can click, crop and submit. It's so easy. Okay, also one more announcement is our plus subscription. This is for our plus students. Okay, so if you there is a doubt challenge going on, that is Amazon gift vouchers will be gifted to 100 learners who's uploading maximum number of valid doubts, and this is starting from 29th of November till 5th of December. I want all of you to participate. Also, if you're taking our iconic subscription, you'll be getting 1:1 live mentorship. That is your discussion of doubts, clarification of concept and live mentoring. Everything will be done 1:1. Okay. So shall we start today's session? Are you all ready? Ready all of you? What is happening in the comment box? Yes, so there are keywords. If you want to find out the flow of all the lectures, you just have to type in the keywords, say matrices or lecture 1, part 1, like that. You just have to type in the keywords. Okay, trust me, it's not that hard to find out. Okay, perfect. Shall we start? Ready? I want some response, kids, in the comment section. Active participation in comment section is very necessary. Okay, so we are going to start with our topic, that is matrices. Matrices. Spare with my handwriting. Okay, so today we are going to learn matrices. Say in one stretch we will be completing 1/3 of the chapter. Okay, most probably more than 1/3. Okay, so we'll start with the definition of matrices. What are matrices? Tell me. So matrices are arrangement of, say, numbers or elements or alphabets also, okay, in a certain manner. So how is this pattern in which you will be arranging the elements? It will be, say, you will be representing any matrix using the letter. Say capital letter you will be using to represent any of the matrix, okay, not small letters. Okay, clear? One second. Let me see you all properly. I'll keep it here. Okay, so you'll be using capital letters to represent your matrix. Say capital A I can write. Okay, so matrix, one matrix is said to be a set of numbers. Say how many numbers will be there? We can say there can be m by n, n cross n it is written. Okay, so there are a total of m by n or m into n numbers in total will be there, which will be arranged, say, in a proper number of rows and columns. So how many rows and columns will be there? The first one in the order will be giving you the number of rows. Okay, this will be the number of rows. Okay, and the second part will be giving you the number of columns. Okay, number of columns. So the total of m rows and m columns. How will you represent it? Say the first element A11 will be here. Okay, so rows are nothing but, there are m rows, right? So rows are nothing but your horizontal lines. Okay, rows are nothing but your horizontal lines. These are your rows. And what will be your column? It will be your vertical lines, or vertical arrangement is called as your columns. Okay, so there are total n columns. So that means the first row will contain n elements starting from 1 to n. So A1n will be your last element in your first row. So likewise, what will be your second row? It will be second row, first column, second row, second column, likewise till second row, nth column. And likewise, it will go till your mth row. Mth row, first column, mth row, second column, likewise till mth row, nth column. Understanding all of you? Any doubt? Are you all understanding? Any doubt? And okay, perfect. And this representation should be given in, say, square brackets. The elements will be represented inside big square brackets. So this is how we generally write. So tell me, in this, say the number of rows into number of columns, or number of rows by number of columns ka representation is called what? It is called as the order of your matrix. So this is the order of the matrix. And how many elements are there in total? The total number of elements. The total number of elements in this matrix will be nothing but m into n. M into n elements will be there in total. Okay. Now, any matrix can be also represented by, say, A, I, J in square brackets. Okay. And the order of the matrix should be written outside in the right corner, bottom right corner. Okay. So what does it represent? A, I, J will represent each element in the given position. How will you get the position? It will be, say, for Aij, the element will be on ith row, okay, ith row and in jth column. Understanding? Ith row and jth column. Okay, clear? These are the basics that you have to know when we are talking about matrices. Okay, perfect. Now, next we are moving on to types of matrices. Okay, next we are moving on to types of matrices. Types of matrices. So, there are different type of matrices. I want all of you to write along with me so that you will remember. Okay, the first one. Yes, the first one being a square matrix. Square matrix. Okay, what is a square matrix? A square matrix is nothing but a matrix, okay, having the number of rows and the number of columns equal. When the number of rows is equal to number of columns, we call it as a square matrix. Okay, number of rows equal to number of columns, we call it as a square matrix. We can simply write a square matrix how? Like this. Okay, square matrix A of order, say, n. What does it mean? It implies that the order of the matrix will be n cross n. Okay, n cross n will be the order of the matrix. How can I represent an example of a square matrix? Is that, say, a small 2 by 2 matrix I'll show. So, A, B, C, D. This is how my matrix will look like of 2 by 2 or 2 cross 2 matrix. Okay, very good. So, this was square matrix. What is a square matrix? When your number of rows and number of columns were equal. So we are defining a matrix with respect to our rows and columns. Okay, so the second type is nothing but a horizontal matrix. Horizontal matrix. What is a horizontal matrix? When your number of columns is greater than number of rows. So horizontal matrix means a matrix whose elongated in horizontal direction. In horizontal direction, what it will be? Clearly, in horizontal direction, the number of columns is what is determining whether which matrix it is. So horizontally means the number of columns should increase rather than the number of rows. That is why we say when number of columns is greater than number of rows, when number of columns is greater than the number of rows, okay, we call it as a horizontal matrix. Okay, clearly it will be a rectangular shape. Rectangular shaped matrix it will be. For example, say if I have a row of elements, say A, B, C, next row can be D, E, F. So clearly my number of rows here is 2 and number of columns is 3. So 2 by 3 matrix which is of a rectangular shape, and clearly this is elongated, or the rectangular shape length is more where in horizontal direction. So we call it as a horizontal matrix. Okay. Next we are learning about vertical matrix. Okay, vertical matrix. Hello, Royal Gamer. Vertical matrix. Then sit for my class then. We'll explore matrices. Vertical matrices. So what do you mean by vertical matrix? Tell me. This you must be knowing. When your number of rows is greater than number of columns. So vertically the rectangle should be elongated. So number of rows will be greater than number of columns. Okay, number of rows is greater than number of columns. 1 second. Yes, perfect. So how it will clearly of a rectangular shape. Okay, even this will be of rectangular shape. Even this will be of rectangular shape. Array yaar. Rectangular shape. Okay. So, for example, it will be, say, number of rows should be greater, right? So, A, B, C, D, E, F. There are a total of 3 rows and 2 columns. So 3 by 2 matrix it will be. Okay, very good. Now moving on to next type of matrix, which will be our row matrix. So the name itself suggests, right? It is a row matrix. What is a row matrix? When there is only one row exists. Number of columns can differ, or more than one columns should be present. More than one, any number is fine, but number of rows should be just one. Okay, so when your number of rows, okay, is equal to 1, or when just only one row exists, you call it as a row matrix. Say A, B, C, D, like this. This is a row matrix where it will be 1 by 4. Okay, 1 upon 4. Okay, 1 cross 4 matrix it is. And then obviously the next one will be what? A column matrix, right? If you are talking about row, obviously the next one will be a column matrix. How to get rid of this? So, column matrix. Column matrix is what? When the number of columns is 1. Only one column should be there. Number of columns should be equal to 1, then it is a column matrix. Okay, so we have A, B, C, D. 4 cross 1 it is. Okay, very good. Next, we are moving on to our next set of types of matrices, that is our diagonal matrix. Very important it is. Okay, diagonal matrix. So I believe it is a sixth diagonal matrix. What do you mean by diagonal matrix? When your elements along the diagonal only exist, that means the rest of the elements should be equal to 0. Along the diagonal you have elements, but the rest of the elements are 0, then you call it as a diagonal matrix. The important points that you have to remember for a diagonal matrix is what? It is a square matrix. Remember that all diagonal matrices are square matrices. Okay, 1 second. Square matrices. Okay, it is a square matrix, and what is a, so any Aij, okay, Aij will be equal to 0. For what? For all I not equal to j. For all I not equal to j, you will have Aij equal to 0. So what it will be? A11 has I and j equal, so the condition does not satisfy. But A12 means what? My I not equal to j, that is 1 not equal to 2. So clearly my next element will be 0. A13 also will become 0. Okay. Now again, if I am considering A21, again I value is 2, j value is 1. When I not equal to j, we have Aij to be equal to 0. Then we have A22 and then again 0, 0, 0, A33. So clearly along your diagonal, we will have the elements, rest all the elements are equal to 0. Also remember that, okay, your A11, A22, A33, such elements are called the leading elements. Remember that these are called the leading elements. Okay, and the leading diagonal elements also you can write. Leading diagonal elements. So you might be thinking that the diagonal can be this way also, right? This also can be considered as a diagonal for a square matrix. That is why we specifically said leading diagonal elements. So leading diagonal elements will be always this, which is that when I and j values are equal, you call it as the leading diagonal. For a leading diagonal, what is the property? Your I value should be equal to j. Okay, I equal to j is the meaning of leading diagonal. Okay, now If my diagonal elements, if I say if my diagonal or the leading diagonal elements, instead of getting values, if my diagonal elements become what? Equal to 0. Even then, it can be considered to be a diagonal matrix if the rest of the elements, say I not equal to j elements, are 0. Okay, even if my diagonal elements are 0, it's fine. Okay, it's fine. It's okay. Why? Because the only condition is that I not equal to j values. Okay, I not equal to j elements should be equal to 0. Okay, the elements whose I value is not equal to j, that should be 0. That is the only condition to be satisfied. Also remember that we can write a diagonal matrix with the help of its leading diagonal elements. Like, if I want to write this matrix, I can also write it as, written as diagonal DIAG. Okay, DIAG only you will write. Diagonal elements A11, A22, A33. So like this also we can write a diagonal matrix. Okay, say for example, I have a matrix, say A equal to 2 0 0 0 5 0 0 0 7. This is my matrix A. Clearly, when I not equal to j, all the elements has become 0 and we have only for I equal to j. The leading diagonal elements are only existing. So clearly, this is a diagonal matrix. So this can be also written as what? A is equal to diagonal matrix 2, 5, 7. Like this also we can write. Clear, I believe, for all. Okay, perfect. Now, moving on to your next type of matrix, that is 7th one, scalar matrix. Scalar matrix. So remember that scalar matrix is a type of diagonal matrix. It is a type of diagonal matrix. Okay, and what are diagonal matrix? Diagonal matrix are square matrices. So it can finally implies that any scalar matrix is also a square matrix. Okay, scalar matrices are basically developed or taking all the conditions of diagonal matrix, and then in that case any scalar matrix will become a square matrix as well. Okay, so what is the speciality of this scalar matrix? How does a diagonal matrix become a scalar matrix? Is that when, okay, your diagonal elements is a single value. Okay, when all diagonal elements are same value or equal in value. Okay, same in value or equal in value, you call it as a scalar matrix. Say for example, say you have 2 0 0 0 2 0 0 0 2. So basically, as we can see, this is a square matrix because it is a 3 by 3 matrix. 3 by 3 matrix, a square matrix. Okay, and it is a diagonal matrix. Why? Because all the elements other than the diagonal elements are 0. Okay, now this is not just any diagonal matrix, it is a scalar matrix. Why? Because along the diagonal or the leading diagonal elements were all same or equal in value. So we call it as a scalar matrix. Okay, perfect. Now, then tell me, what do you mean by identity matrix? Okay, 8th one is called the identity matrix. So this is a very important one. Identity matrix. So what is an identity matrix? You can also call it as unit matrix. Unit matrix. You can also call it as unit matrix. So what do you mean by an identity matrix or a unit matrix? Clearly, any identity matrix is a scalar matrix. Scalar matrix is this. Okay. So it is any identity matrix is a scalar matrix, that is the leading diagonal elements will be equal basically, and it will be equal to 1. That is why we call it as identity matrix or unit matrix. Okay. So basically any identity matrix will be a scalar matrix. If it is a scalar matrix, then for sure it will be a diagonal matrix. Okay. We are finding the relation. Then it will be a diagonal matrix. Then if it is a diagonal matrix, for sure it will be a square matrix. So remember that when I basically say an identity matrix, it will be square and it will be diagonal and it will be scalar as well. And what is the speciality? All those diagonal elements. The speciality or what makes a scalar matrix to an identity matrix is that all the diagonal elements are equal, and it is equal to what? It is equal to 1. All diagonal elements are equal to 1. You call it as a identity matrix. How will I write it? It is a unit matrix as well. So 1, 0, 0, 0, 1, 0, 0, 0, 1. This is called an identity matrix with 3 by 3 order. Okay. 3 by 3 will be the order. Now, how do I write it? Any identity matrix can be written as I suffix n. Why n? N is nothing but the order of your square matrix. So, this can be written as I3. Got it? Any doubt? Clear, I believe. Okay. We have 3 more matrices, types of matrices to be learned. With that, 3 will be coming to the end of types of matrices. Okay, so that would be which is the next one? Ninth matrix, which is a null matrix. Null matrix. What do you mean by null matrix? As the name suggests, null means 0. It is also called as zero matrix. The term 0 for our matrix as such is not there, right? So when we are talking about matrices, we are not just talking about any integers. Say matrix 1 and we are not telling. It was all about collection of elements, right? So we need the concept of 0 in matrices as well. That is why we introduced null matrix or 0 matrix. Okay. So remember that basically any null matrix is a square or a rectangular. Doesn't matter. The size or the order doesn't matter. As per our requirement, we can select our null matrix. Remember. Okay. So, a null matrix can be a square or a rectangular matrix. Okay. It can be a square or a rectangular matrix. Okay. So, that means it can be of any order. It can be of any order. Okay, and it is used for helping your calculation in matrices. Okay, this can be also called as 0 matrix. Okay, so this is simply how, if I need a 2 by 2 null matrix, this will be my 2 by 2 null matrix. Or if I want 1, 2, 3 columns and 2 rows, a rectangular one. Okay, all of these are null matrices. Okay, as per the use in which my calculation has to be done, there I will be using it accordingly. Okay. Yes. So, the next one is our 10th one. Which is my 10th one? Upper triangular matrix. Upper triangular matrix. Or do you want me to write the whole thing? Upper triangular matrix. upper triangular matrix. So what is an upper triangular matrix? It is clearly, it should be a square matrix for sure. Okay, and all the elements, say your Aij element will be equal to 0. For what? For all I greater than j. Whenever I is greater than j, Aij, that element will become equal to 0. And how do I represent it? Say A11. Okay, a 3 by 3 matrix I am going to write. So 3 by 3 matrix means 3 rows and 3 columns. So I value will range from 1 to 3 and j value also will range from 1 to 3. First element being A11. I and j equal to 1. A12. I is less than j, so that can be written. A13. I again less than j, so that is also fine. A21. 21 means I value is greater than j, then in that case what happens? My element will become equal to 0. That means this element will be 0. Again, A22 is my next element where I and j values are equal, so I can write for the same. Again, A23. I value less than j, so the condition is not satisfied, so A23 exists. Now moving on to my next element, A31. I greater than j. So what happens to my element? It will be equal to 0. Again, A23. Okay, sorry, 3, 2. Okay, third row, second column. So clearly what? I value again greater than j, so it should be equal to 0. So this is also 0, and finally A33, I and j value equal. So this is called as upper triangular matrix. Why do we call it upper triangular matrix? If you observe, the number of non-zero elements which exist will be what? The number of non-zero elements which are existing is along the upper side of your square matrix. Okay, because the lower side of the square matrix will be full of 0 elements. Okay, perfect. Now, moving on to my 10th or 11th or the final type of matrix. Okay, which is that my lower triangular matrix. So it is just the ulta of this, right? Lower triangular matrix. Okay, lower triangular matrix. So as in the case of upper triangular matrix, for lower triangular matrix also it should be a square matrix. It should be a square matrix, and my Aij value should be equal to 0 for all I value less than j. That is the condition here, ulta condition. Okay, so what it will become? It will be A11. Okay, A12 will become what? It will become equal to 0. So this will be 0. A13 will be also satisfying the condition. So 0. A21 will be given. Okay. Then we have A22. Then we have the next element to be 0. And then again A31, A32, A33. Okay. So why do we call it as a lower triangular matrix? Because the non-zero elements will be on the lower triangular side of your matrix, square matrix, from the leading diagonal to the lower side of the lower triangular elements of my matrix, square matrix. Okay, perfect, very good. Now we are done with the types of matrices. We are moving on to the next thing, that is operations or algebra. Okay, algebra of my matrices. Operations or algebra of my matrices. Okay, 1 second. Yes, perfect. So, operations or algebra. Algebra of matrices. Okay, algebra of matrices. What is the first one? Equality. Okay, equality. Now, what do you mean by equality? The matrices. Two matrices I'm going to compare now. Okay, when the two matrices have, okay, and the comparison of the matrices should have what? Some conditions are there. What is it? Same order. Both the matrices, okay, who we say that are equal or the equality symbol exists, then it is known as they should be having the same order. Okay, and why they should be having the same order? Because all corresponding elements are equal then in that case. Okay, equality means what? All corresponding elements are equal. All corresponding elements are equal. Okay, now shall we do one example and check? Check it out, everyone. The example is that given 2x plus 4. Okay, before that, let me explain a normal one. Okay, so you have A, B, C, D matrix. I am just writing a 2 by 2 matrix equal to E, F, G, H. Okay, so what does it mean? If I say two matrices are equal, what is the first thing I have to check? Yes, both are of same order, 2 by 2 and 2 by 2 matrix. Okay, and the corresponding elements then in that case will be equal, we said. Which are the corresponding elements then? The element A, 1, 1. Okay, the first element will be equal to the first element in the next one. Same way, B will be equal to what? F. So, A will be equal to E, B will be equal to F, C will be equal to G, and D will be equal to H. Okay? Perfect. Very good. Hello, Annamale. Welcome to the class. Okay. Now, next, let us do a question. Okay, of equality. We are going to do a question. Try this question, Annamale. So, we have 2. This is a one question, okay. 2x plus 4, 3y minus x, z plus 2, okay, and x plus z. This is one matrix. Given this is equal to 0, 5, 3, minus 1. What I'm supposed to find? I'm supposed to find the value of x plus y plus z equals. Okay, x plus y plus z value is what I'm supposed to find. Okay, so clearly I can just check the corresponding values. What will be the corresponding values? Clearly, since their equal to sign or equality exists, I can understand that 2x plus 4 will be equal to what? 0. Okay, from which I will get my x value to be equal to minus 2. Okay, then I have 3y minus x to be equal to 5. And what is x value? It will be equal to minus of minus 2, which will be plus 2 equals to 5. Which implies y value will be 5 minus 2, that is 3. Then upon 3 will give you 1. Y value is 1. And finally, I will get z plus 2 is equal to 3, which means z value is also equal to 1. Okay, so they have asked for x plus y plus z, which will be minus 2 plus 1 plus 1, which is equal to 0. Hence, 0 will be your answer. Clear? Any doubt? So, this is the significance of equality, corresponding, all corresponds. It should be of same order and all corresponding elements will be equal. Okay. Moving on to your next operation, that is addition operation. Addition operation. How do we do the addition operation? Is that even for addition operation, the order should be same. That means it should be of same order. Okay. Now, corresponding elements should be added here. That is the difference. Okay. So, the corresponding elements were equal in equality. For addition, the corresponding elements should be added. Okay, say for example, I have A, B, C, D. Okay, then I have E, F, G, H. The addition of these two I am supposed to write. So the corresponding elements should be added. So the corresponding elements will be A and E. So A plus E. Then B and F. So B plus F. Then C and G. So C plus G. And D and H. That will be D plus H since it is addition. Okay. So remember that for addition, there are few properties which we will discuss after just an example question. Okay, example question, that is, if I have a matrix A, say 2, minus 1, 0, 6. Okay, if I have a matrix like this, and another matrix B of elements 4, 7, 2, minus 2. Okay, then if I have to find out A plus B, what is the first thing I'll check? Whether the order is same or not. Obviously, the order is same. So what will be my next step? My next step would be addition of corresponding terms, which is it 2 plus 4, that is 6, 1 minus 7, minus 1 plus 7, which is again 6, 0 and 2, which is 2, and 6 and minus 2, which is 4. That would be my A plus B ka solution or addition of A and B matrices. Okay. Now, there are few properties of addition. Properties of addition of matrices. The first property being what? It is commutative. The first property being commutative. Which is the commutative property? A plus B equal to B plus A. Okay. Commutative property of matrices means A plus B will be equal to B plus A. Associative. Second property is any matrix addition does apply, or associative property is applicable for matrix addition. Associative property. That is A plus B plus C is equal to A plus B plus C. Okay. And next, remember that the cancellation law holds. What does it mean by cancellation law? Cancellation law holds. What do you mean by the cancellation law? If I have A plus B equal to A plus C, then it simply means that B will be equal to C. Okay, A plus B equal to A plus C simply means that B will be equal to C. That is the meaning of cancellation law. Okay, next, moving on to my next algebraic operation or algebra of matrix will be what? Subtraction. Subtraction of matrices. Subtraction of matrices means what? The matrices will have the same order. The matrices will have the same order, and what we have to do, the corresponding elements should be subtracted. The corresponding elements should be subtracted. Okay. So, do you want to do an example? I believe not. Right. Same as that. So, there are no properties as such that we are learning for subtraction. And next, we are going to learn about multiplication. This is very important, kids. Multiplication. multiplication of matrices. Okay, so there are two types of multiplication. The first type being scalar multiplication. Scalar multiplication. And the second type being multiplication of two matrices. Multiplication of two matrices. So what do you mean by scalar multiplication? A scalar quantity. Remember that a scalar quantity here just means that it is an integer. Okay. So, or a rational number. So a real number or a rational number when it is being multiplied to a matrix is the meaning. Say for example, you have a scalar quantity, say k into a, simply means that the scalar quantity is multiplied with each of the element in the matrix A. Okay, how do we know that? Say consider A is equal to the matrix 2, minus 5, 7, 3. Okay, and if I have to find out a scalar multiplication, what is it? 2 times A. In that case, what it will become? Each element in the matrix A should be multiplied with 2. That is 2 into 2. That is the first element, which will become 4. 2 into minus 5, that will be minus 10. 2 into 7, which will be 14. And 2 into 3, which will be 21. Okay, so this is called as scalar multiplication. Now, what do you mean by matrix? Two matrices ka multiplication. It is an arrangement of the rows and column multiplication. Okay, which is a pattern which all of you must remember. You have to study by practicing a lot of your multiplication ka term. That is row by column. A row is multiplied with a column. That is called as matrix multiplication. Two matrices ka multiplication. Say for example, if I have A, B, C, D being my first matrix and E, F, G, H being my second matrix, dono ka, the two matrices ka multiplication will be what? This is my first row, that is R1, second row, first column, second column. So, the first element of the multiplication of two matrices will be formed by the product of the first row and the first column. That would be, how is the product formed? It will be, say, A into E and B into G. A into E and B into G. This will be the multiplication to be done, and the summation of both of these products will be kept together. Okay. Now, again, what will be the next one? It will be the first row and the second column. Okay. So, how it is done? Oh, sorry. One second. Yes. So, how it is done? We have our row 1, column 1, row 1, column 2. Okay. And then again, let me write the elements. It will become A into F and B into H, their summation. Next, it will be what? Second row. Okay. That is R2, C2, and then it will be R2, C1 in the previous case. R2C1 and R2C2. Those elements will be what? C into E and D into G ka summation, then CF plus DH. This would be your product of the two matrices. We shall look into this with the help of an example question. Listen. So consider that matrix A. Consider my matrix A to be equal to 1, 2, 3, minus 4, 5 and 6. And I have a matrix B to be equal to 4, 5, 6, 7, minus 8, 6. So remember, in the matrix multiplication is that first you have to check the order. What should be the order? Say here you have an order, say 3 by 2, and here I have the order 2 by 3. Okay, so remember that the number of rows, I'll write here, the number of columns of the first matrix should be equal to the number of rows of your second matrix. Okay, number of columns of first matrix should be equal to the number of rows of second matrix. Okay, so that means you can see for yourself 3 cross 2 and 2 cross 3. The number of elements in the number of rows and columns of second and first matrix are equal. Now, then in that case, what will be the final element or the product ka number of rows and columns will be what? It will be 3 cross 3. The remaining number of rows and columns ka combination. Okay, let us see for ourselves what is A into B in this case. Okay, it will become first row and first column. So it will be 4 plus 14. Then we have first row, second column, that will be 5 minus 16. Then first row, third column, that is 6 plus 12. Then again we have second row, first column, that would be 12 minus 28. Then again 15 plus 32. Okay, and then we have 18 minus 24. And finally the third row and the next 3 columns, that would be 20 plus 42. Okay, then we have 25 minus 40. You have which is this? Yes, so 25 minus which row and column is happening? They are, 1 second. Wait, let me see the comment box. Okay, perfect. So third row, second column, 5 into 5, 25, 6 into 8 minus 48. Then we have 30 plus 36. So these will be the elements whose ka addition and subtraction and all you can do inside, and you can write it. That would be, the first one will become 18. The class is about to end, all of you. So again 18. Okay, then we have minus 11, then we have again 18. Likewise, you can write all of the elements and that would be your product. Okay, so the continuation of this will be dealt in the next class, that is properties of multiplication, then transpose, trace, all of this will be discussed in the next session. I'll see you all tomorrow afternoon 2 p.m. Till then, take care and bye.